use buttons instead. So mobile communications, I mean, most people associate with connecting people, people connecting to each other. So this is sort of the normal picture that you see when you think about mobile communications. And of course that is to a large extent true. Now, the interesting thing is that this technological development is not slowing down by any means. So I sometimes say this, you should enjoy today, because this is the slowest day of the rest of your life. You saw the numbers, they are huge, but the truth is that in just a few years, people will be outnumbered by machines on the internet. The internet will be mainly for machines, for things, talking to each other. And they will share more data than we share between ourselves today. And to support this development is really, that's really what 5G is about. There's a long history of telecommunications, or communications mainly for people. It took almost 100 years to connect 1 billion places, because with wired telephony, you connected places, not people. You called an address, you didn't call a person. Then it took another 20 years to connect 6 billion people. So already that was a rapid speed up. And now we expect it to take another maybe 10 years to connect 20, 30 billion things. So as you see, just a few years from now, there will be far more things connected to the internet than people. So what is 5G then? Well, of course, it will be partly the same thing that we see today. 5G will be just giving you a sort of slightly better smartphone, better connectivity, faster, so on. But it will also mean a lot of new things. It will enable the possibility to use sensors and actuators everywhere. 5G offers energy efficiency and cost levels that have not really been achievable before. It also means that industries and services will become more digital. It will support more efficient streams of both products and services. And then, of course, maybe most importantly, our society will become more digital. Infrastructure, transportation, utilities, water, sewage, electricity will be much more efficient and more sustainable using 5G. So what I believe is that anything that can be connected in the future and benefits from it will be connected. And it will also be smart, and it will interact with this environment. And this is, of course, a dramatic change for everything that we do. So, another example of what 5G means and why we need it is here. Here we have a robot that's actually controlled by a cloud application, and we start out at 5G speed, which is about 10 millisecond delay in the communication. That is not achievable today. Then we gradually increase the delay, and we're not yet at sort of today's levels. In a good Wi-Fi network, you get like 50, 60, maybe 70 milliseconds a delay. In a good 4G network, you maybe get something slightly less, maybe 60. What you see now is that as we increase the delay, and we are not yet at Wi-Fi speed, this is still faster than today. It's starting to get a bit sort of shaky. And now we're getting close to where today's Wi-Fi and 4G is. So in summary, I mean, if we want to control things, physical things, wirelessly, I mean, we cannot rely on today's technologies. We need something new. And this new, I mean, we need to go to the fourth step. I mean, I'm sure you've seen this chart before. That's sort of the fourth industrial revolution. And I mean, industry here is in a wide sense. I mean, this of course includes agriculture as well. I mean, agriculture and food production and food development has gone through all the same steps. And to get onto this sort of fourth level in the development of our society, I mean, we need automation, we need wireless connectivity, we cannot rely on wires everywhere. We need information processing, artificial intelligence, and we need virtualization. Virtualization in terms of, for instance, digital twins and remote operation, and things like that. And to realize this, I mean, AI is at the core of this. It's machine-supported and machine-executed intelligence. So to achieve the type of circular economy, I think Joachim had a nice picture before showing how, I mean, you can create this circular economy around food. This has a slightly different, slightly larger scope. I stole it from agriculture. You really need the elements of digitalization. You need the connectivity, you need the AI, you need the data processing. To do everything, to monitor and control everything from irrigation to fermentation to production to transportation, to realize this type of sustainable circular economy. Now, digital technologies has an interesting feature, and that is that they are sort of borderless. If we look at the typical value chain for food production, sort of from field to table, it's often quite regional. I mean, a complete value chain can be maybe, I mean, 20, 30 kilometers in total geographical coverage. But digital does not sort of does not have that limitation. And also, I mean, in food production being very local and limited, geographically limited is sort of a positive thing. With digital, there is no such cost. I mean, you can be global without any additional cost. And that means that you can, for instance, you can benefit from data collected in on a completely different continent. You can improve your food production, your farming here in Sweden based on data in a completely different part of the world, but maybe with similar climate, for instance. And as Joachim was mentioning, I mean, we can even make it a business. I mean, because I think in Sweden we are really good at systemic solutions. We have sort of an engineering culture and a heritage of developing complete solutions, sort of end-to-end solutions, ranging from, again, I mean, from the field to the table. And if they are relying on digital technologies, and they're based on digital technologies, that's a knowledge and sort of an approach that we can actually sell and benefit from. One example that we have in Ericsson when it comes to these systemic solutions is an innovation project that's run by my team in Pisa in Italy. Pisa lies in the region of Tuscany, and it's kind of interesting because Tuscany shares a lot of characteristics with Skåne. They have a fairly progressive regional government. They have a strong agricultural sector. They have some quite innovative companies. Piaggio, making the Vespa scooter, for instance, is one of them. Prada, the fashion company. Ferrari, the car maker, and so on. Here, my team is collaborating with a company called Zucchetti. And it may not be very well known to you, but if you have a Husqvarna automatic mower at home, it's actually designed and manufactured by Zucchetti. They just put a Husqvarna sticker on it. Now, the map to the left here shows the vineyards, the density of vineyards in Tuscany. As you can see, there's a lot. And wine is actually one of the main goods produced in Tuscany. Of course, they have other agriculture as well, but we decided to focus on the wine industry. for a number of reasons. One is that it has a number of challenges. It has a sustainability challenge. Historically, there's been a fairly extensive use of chemicals and pesticides in the wine industry, much more than you actually want to know. And this is something that the region of Tuscany wants to do something about. They want to make it more sustainable and more sort of ecological wine manufacturing, wine sector. And in doing that, unfortunately, that ends up being very labor intensive. Because if you want to not use pesticides and not use chemicals, you have to do a lot of manual labor instead. That makes the wine very expensive. So it's sort of it's a catch-22 or a dilemma for them, because they want to make a more sustainable wine industry, but at the same time they cannot really accept the costs today. So what we're looking into together with them is to make this roboticized. So together with Zucchetti, well actually Ericsson is not developing this is a Zucchetti product, but we're helping them develop it. And of course we're not doing it to sell things. I mean, this is mainly to develop the 5G ecosystem and to show the world the potential of 5G. So this is the AgriRobot, and it's actually based on many of the technologies used in automatic lawnmowers as well. But it has some new features. For instance, there are some weed cutters here on the side. So when it walks around in the vineyard, it can actually cut weeds. And just cutting the weeds is it's a very good way to reduce the attacks of both fungi and insects on the vines. So what this robot does is that it walks around in the vineyard, and it has cameras. It can actually identify through machine learning. It can identify diseases and insects on the plants, and you can have a very targeted effort. It can actually even spray pesticides locally. Of course it cannot see insects themselves with the camera, but it can, for instance, there are certain larvae that makes the leaves curl up, and you can identify that instead. And then you know that you have that particular problem in that part of the vineyard. But you can also see discoloring of leaves and things like that. And this is of course just one end of the value chain. I mean, the vineyard is just sort of the starting point of this whole value chain. So we're also looking at, together with some other companies, is to make the entire value chain digital. The winery plant, the logistics, the delivery, the aging, and the sort of the vision here is to make a single grape traceable all the way to the glass in the other end. So you know that you can basically tell from the bottle exactly where the grapes grew and who vinified them and where they were stored, and you can trace that whole chain. And this is really interesting for the winemakers, because winemaking is actually, I should say, very subjective or emotional business. It's very much about trust in the brands. It's about sometimes selling more of an emotion than a beverage, actually. So the ability to connect the wine bottle back to a farmer is in a special place. It's actually a great value for the wine brands. So, and this we also demonstrated. This is actually not a new project. We've demonstrated this at the Wine World Congress back in 2016. But we have developed it since. I mean, this is just the first ideas, and today we have more of a full-scale prototype in Pisa. So overall, I think the opportunities for digitalizing agriculture is really interesting. And looking at the 17 sustainability goals that the UN put up, I mean, of course there are 4 here that may be more addressed than others, but I believe that AI and digitalization of agriculture and food production will actually address pretty much all of the 17 goals, which makes it just even more important. So in summary, I think the future of agriculture and future of food tech really relies on these three pillars, and it's 5G, it's cloud technology, and it's AI. Thank you.
Thank you, Björn. Everyone is really good at keeping their time slot here. Any questions for Björn before he leaves the floor?
Yes?
We talked earlier about remote sensors. We see in certain countries the use of low power network because for different reasons, but one reason is because 4G is not accessible, especially in the farming areas. How do you see 5G will be better and maybe work in parallel with low power network? What's your view on?
I think the low power networks like Sigfox and LoRa and so on, they feel a niche. For really super inexpensive devices, like sensors, they can actually be a good alternative to more complex technologies. The downside with those systems is that they have sort of there is a level of saturation. So when you reach a certain proliferation of such devices, the network will actually more or less stop functioning. So you have to manage the number of devices quite carefully. 5G will not have that kind of sort of limitation. Another issue is security. The level of security in those systems is limited. So if you have, how should I say, things that are critical, having to do with maybe water or electricity or traffic in a city, you may not want to use such sort of simple systems because they can be hacked. And the third thing is really the uplink capability, because all those systems are, downlink. All those systems are made to mainly transmit data from the device. And if you have, and you cannot really, there's no effective way to send a lot of information down to the device, which means that if you need to reprogram the device, it's pretty much impossible. So if you have 1 million devices out there and they get the virus, you're screwed.
Any questions? All right,
Thank you.
Very much.